scientists, welcome back. It's Mrs. Perlin. Last time that we were together, we were talking about why the playgrounds at Woodland and Carver Elementary, why they were getting warmer in the afternoon than opposed to the morning. Because we knew that the sun was shining on the surface, making it warm, but we couldn't figure out why was it getting so much warmer in the afternoon. So we made the model and we tried to figure out why, with the model, why the surface is getting warmer in the afternoon. We realized this key concept, right? We realized that the longer light shines on a surface, the warmer the surface gets. So we're going to look at some pictures today to talk about which picture is warmer and why. Here we go. So first up, we have the rocks from the story that we read in our last lesson. So point to the rock that you think is hotter. The one on the right, right? Because the lizard's getting off of it. And so why is that rock hotter? Because the sun was shining on it longer. So I'm guessing that's the afternoon picture, and the one on the left with the lizard on it is the one from the morning where the rock wasn't quite as hot because the sun was not shining on it for a long time. Next, we have this picture of someone standing in the sand. So on the left, he is wearing no shoes because the sand is not very hot. In the picture on the right, he's wearing his boots because the sand is really hot. So point to the picture that the sun has been shining on longer. Hopefully you're pointing to the one that the man is wearing the boots because it's so hot that he can't just go on bare feet. So this is showing me that the sun must have been shining a lot longer on the sand on the right. Next we have a chocolate bar. Okay, so which surface temperature do you think the sun has been shining on longer? The one on the right or the one on the left? The one with the melted chocolate bar or the one that's not melted? Hopefully you're thinking the one that's melted, the sun must have been shining on that surface temperature for a long time because it made the candy bar melt. And on the right, the surface temperature must be cooler because the candy is not melting. Okay, so now let's make some predictions about Carver and Woodland Elementary because I have their playground data. I have their data from what the temperature was at night, what it was in the day, and what it was in the afternoon. I should say in the morning and then the afternoon. And so I'm going to give you the nighttime temperature and the afternoon temperature, and I want you to predict what is going to be the morning temperature. So let's take a look at that data. So now we're going to look at Carver Elementary's temperature data. And you can see on the left that at nighttime, it was purple every single night, which means that it was very cold on our thermometers. I'm not going to give you the morning recess data yet. We're going to look at the afternoon. So in the afternoon, it was yellow and orange. Remember, yellow means warm and orange means hot. So what do you think the morning recess temperature was? Do you think that it was cool, which would be green, and cold, blue? Do you think it was very hot or hot? What do you think the morning was like? Hopefully you're thinking, well, it's gotta be cooler than warm and hot. So maybe it was cold and cool, which would be green and blue, because that's what my brain is thinking. Let's see if you're right. Oh, it was green and blue. It was cool and cold. So we were right, weren't we? Because that will show that yes, it was purple, cold in the morning. The sun came out and warmed it up some to cool and cold. But then as the sunlight was shining on it for a longer time, it became warm and hot. All right, let's check out Woodland now. So looking at Woodland Elementary's data, you can see the same thing is true, right? At nighttime, it was very cold. The sun comes out, it warms up the surface of the playground to be warm and cool, and then as the sun shines on the surface longer, it turns into hot and very hot in the afternoon. So this real world data seems to go right along with what our model was showing us in our last lesson, that yes, the longer the sun shines on a surface, the warmer it's going to get. So thinking about our language framework and always talking like a scientist, let's think about what we already know about cause and effect and how to talk and explain our thinking. So over here I wrote a bit of a framework for us. So it says the surface temperature of the playground was blank in the morning because the sunlight was shining on it for a blank time. So the effect that was going on with the playground is that the surface temperature of the playground was what in the morning? Was it warmer or cooler in the morning? Cooler. So let's write that word cooler here. Okay. So the effect is the surface temperature on the playground was cooler in the morning. Then we have this word because, and that's going to help us explain why this was happening up here. So what was the cause? The cause was the sunlight was shining on it for a what? A long time or a short time? A short time, because this was the morning. So we have the effect that the playground surface temperature was cooler in the morning because, and the cause, the sunlight was shining on it for a short time. So now we're going to use the same language framework to explain the afternoon. So the surface temperature of the playground was what in the afternoon? Was it warmer or cooler in the afternoon? It was warmer. So we're going to put warmer here. So the effect is the surface temperature of the playground was warmer in the afternoon because there's our word that we use to explain the effect, right? And why, or sorry, to explain the cause of what was happening here. The sunlight was shining on it for a blank time. Would we say it was shining on it for a shorter amount of time or a longer amount of time? Hopefully you're saying, Mrs. Perlin, it's longer. That's why it's warmer. So our whole thing now says the surface temperature of the playground was warmer in the afternoon because the sunlight was shining on it for a longer time, right? The sunlight was there all afternoon, making that surface temperature really warm. So thinking back to the playground problem, we know that the sun is obviously part of the reason that the playground is getting so hot. But why is it getting so much hotter at Woodland and not getting as hot as at Carver? So there must be something else going on besides just the sun warming the Earth's surface of the playground. So next time we meet, we're going to talk about another possible reason that this could be happening and see if we can figure out this problem. Until then, see you later, scientists.